Everyone to Flyte's community meeting. Today, July 11. I'm David Espejo, and I will be your host today. So a couple of reminders. First, the meeting's being recorded and it will be posted to Flyte's YouTube channel. And also this meeting falls under Linux Foundation's Code of Conduct. So in summary, be nice to each other. Yeah, nice agenda today. Again, I'm posting here the link to the agenda notes. Feel free to add yourself to attend this list. Would be great to see you there. So anyone joining for the first time besides Jay, I will introduce you in a while. No, seems like it's not the case today. Oh, okay, so let's move to the next item. I will share my screen here. Let me see, not that one. All right, yeah. So news from the ecosystem real quick. Some news that caught my attention for different reasons. The PyTorch approach to ML infrastructure. The team at Runhouse proposing a really interesting way to approach some of the challenges in MLOps. And there's also an interesting discussion in Hacker News around this. So definitely recommend it. You can also comment here if you want. All right, next one, Inflection AI announcing, I think it's not the first time that I see this, but someone announcing the intention to build the largest or one of the largest computing clusters in the world with a bunch of GPUs and some performance benchmarks run that really interesting. And also needed a further clarification on Hacker News around the performance benchmarks. But yeah, interesting to see how much money and talent and time investment going through trying to make LLMs more performant. Inflection AI is the company behind Pi.ai. So yeah, interesting. The fast API 100 release, according to the author, Sebastian Ramirez, who's, by the way, a fellow Colombian, it introduces support for Pydantic version 2. If you're using it, if you're using Fast API and Pydantic version 2, probably you won't get all the massive performance improvements from Pydantic version 2. That's according to the author. Not yet, but you'll still get some really nice performance boost with the new version. All right, and finally, OpenAI moving to GA with GPT-4. Well, GA for the paid users who will be able to use the GPT-4 API. Okay, any other news, any comment around this? Nope. All right, next up in the community or project updates. Well, the Flyte callback for LangChain was merged last week. So we were really happy to see this here. There was a blog post a couple of weeks ago introducing the whole idea of, and the kind of the benefits that the callback has for both Flyte and Hugging Face users. And here it's now merged upstream. So yeah, definitely exciting. And finally, if you or probably someone you know happen to be attending the SciPy conference in Austin, there will be a hands-on workshop happening in 2 hours, led by Niels Ventilen, who is part of Flyte's steering committee, and also there will be open source sprints during the weekend. It's an opportunity to find ways to contribute to open source projects, and one of them is Flyte. All right, so with that, that will be the updates. And unless you have any other update to share here, we can move to the next section, which is roadmap updates.
Awesome. My name is Eduardo. I'm the Eng manager for open source at the Union, and I'll be giving some updates to the roadmap of Flyte. So, Flyte 1.8 is being released today. It's mostly a stabilization release. Like we had a lot of investments in two features that we recently announced, namely image spec and agents. You notice that image spec had a lot of rough edges, and we are constantly improving it. The idea is to make really image spec the de facto way that you think about like building your DAGs. So keep an eye out. Lots of exciting features there. Um, Also, you noticed that there was like a gazillion bug fixes in this release, but I'll call out a few. We have better support for optionals, which is this idea that in languages they have different names. In Python they're called optionals. Some people know them by the maybe monad. So it's great. All you see improvements across a lot of touch points in Flyte, including Flytekit all the way to Flyte console and the backend. So pretty awesome there. um, we've also heard about the fact that using secrets in GCP was hard, so we also fixed that. Now you can have like secrets that can go like cross project in GCP. And one tiny nugget that it's the community always asked about, and we haven't really found a great way of doing it, and we invested in this past release, which is MyPy compliance. So not in this D818 release, like we're just like enabling it for the Flytekit code base, but going forward, and here I'm already speaking about the near future of Flyte and Flytekit. We plan to open this up so that people who install Flytekit and rely on like MyPy and Pyrite and these other static analyzers will be able to also use in their Flytekit code, which is a feature that a lot of people wanted for the longest time, and it's finally happening. One call out is that we have been maintaining a release, a branch for people who couldn't update to protobuf 3. It was the 1.2 release, so we are up to the 1.213 release, and protobuf 3 just hit end of life last month, and with that it also concludes our support. So alongside Flyte 1.8, there will be a final release that will backport, the changes to the 1.2 branch. So we're gonna have one 1.2 release. I think it's 1.214, and yeah, sorry, have to update the protobuf 4 now, I guess. But I'm looking forward, um, looking towards like what Flyte 1.9 and beyond will look like. There are a bunch of features that are coming down the pipeline. A few that I'm super excited about are eager mode. It's this idea that you can have like awaitable DAGs that can be built like programmatically. Um, we also heard the community that the Flytekit as is a massive package, so we're breaking it up in smaller, um, packages. It will still be Flytekit. We'll just use that idea of optional packages that the Python ecosystem kind of like adopted. So expect that Flytekit will Flytekit, the number of Flytekit dependencies that come from, well, by default will drop dramatically. Um, Another feature that is also coming down the pipeline is like it's less of a feature, but more like a hardening of agents, which is one of the bets of the Flyte team. This idea that you'll be able to have backend plugins written in Python with a much better dev experience. So we are finding the rough edges there and helping, the community like come up with a great way of not only writing agents but deploying them, and integrating them into their Flyte workflows in general. We also have some support for, well, we have more support for image spec. So there are some features that are also coming down the pipeline there. And finally, one final feature that I want to call out is um, also came from the feedback from the community. We heard that dealing with data classes and data class like structures like pydantic models, adders, and etc. is hard. So there's a lot of movement contributions coming from the community. So Greg, Eli, Eli, thank you so much. So we're also improving that. It will be much simpler and more powerful to use data classes and pydantic models in the future. um, Final call out, not specific to any feature or anything, but I just want to thank the community. um, a lot of really beefy features are coming and are being worked on with this globally distributed team that is kicking ass. So thank you so much. We would not be here if it weren't for you. And with that, I think we're done with the release updates, David.
Right, that's great. Yeah, a lot to cover. Thank you. Any question, comment around 1.8 release? No. Right. Thank you, Eduardo. So moving up to the next item, this is a section that is intended to be short. The lighting talk is designed for everyone here to share anything you have learned around Flyte, a specific feature, how to use it, etc. In this case, it's me. That wasn't Michael Scott moment. It's me. I've been spending some time with the auth implementation in Flyte in the past couple of weeks. And yeah, the main artifact of this is this PR to update the configuration docs and also the authentication the hard way guide that is also live. But I thought it was interesting to kind of briefly introduce the topic here for anyone out there, especially for those of us who watch the recording. So I will go real quick here. So we'll cover basically why we need auth in general and how it's done in Flyte. So in the top graph, you see kind of the traditional client server architecture where the user will need to provide credentials, let's say username and password, if he wanted to use a client to access a resource protected and handled by a resource server. Here I'm using on purpose jargon from the auth protocol. This is completely auth coming from the auth RFC. So the resource owner is you, the user. The client is whatever program that you're using to try to access this protected resource. That could be handled by, let's say, an API server, or in this case, a resource server. The problem with this form of access is that, well, if the client is compromised, a malicious actor could pretty much access your credentials. And also there's no standardized way to revoke access for a client, for a specific client. Once it has access to a protected resource, there's no really standard way to revoke access, among other complications. So that was the original problem that the auth protocol aimed to resolve, having kind of a mechanism for the resource owner to log in or provide the credentials to a different component, not the client itself, but a different component that is trusted both by the user and by the resource server. And this is the auth server, or the authentication server. And the auth server will basically, if you as a user are successfully logging, and it means that you are authorizing the client to perform an operation, the auth server will emit a token or a permission that the client will use. The token doesn't carry anymore the original credentials from the user. So the client will use the token to request access, and the resource server will approve or not. And finally, it will give the client access to the protected resource. So it's really helpful. Some folks say that the RFC is hard to read. I don't think so. It's really interesting to read. It's a recommended read. But basically, the idea and the steps are here. So there are two main steps. First, you authenticate, or the user performs authentication, which is basically validating that the user is who they say they are. And next, the authorization, which is basically validating the operations that this user is allowed to do on the protected resource, if any. That's great. It has worked well for some time, but there are some places where all this model could break, especially, for example, this is kind of the flow. This all comes from the RFC, from the auth RFC. And these are kind of the flows or the interactions between the client, the resource owner, the user, the client, and the auth server, and the client finally with the resource server. The problem is that when the auth server responds the user with an access token, typically this path is not TLS secure, is not secure. So a malicious actor or a man in the middle could kind of intercept the token and use it to access resources on behalf of the client. So this is a problem, and there are different ways to manage this, but I will say the whole category of the response that the auth server provides to the client is the there are 4 or 5 types of responses. The first is the classical authorization code that will make use of the auth server. There's another form of permission or authorization grant, which is the implicit authorization, not really recommended because it gives the client an access token directly. It's not great. The other one is client credentials. It is when the client has a let's say a predefined, pre-established trust relationship with the auth server, and it's able to store some credentials to go to the resource server and request access. So it's typically used for example, for CI infrastructure, where this system is not really a user, but is trusted, and it's able to restore credentials, and you assume it won't be easily compromised. And kind of the most popular way to address this problem is using the PXE flow. It's a kind of a separate protocol on top of auth, and uses a verifier, a code verifier, to mitigate this problem of the interception attack. So the path is still insecure, but the client or the malicious actor will need to present a verifier code that probably won't be able to get easily, and it will prevent or mitigate the risk of this kind of attack. So and finally, the device flow, it's also a separate RFC. The original design was for devices that don't have a browser, and but enables users to review an authorization request on a second device. So the good thing is that all of this is available in Flyte. Is the first thing that was surprising for me, pleasantly surprising for me, to find how kind of easy it is to access OAuth compliant implementation in Flyte of both the PXE flows, device flow, even client credentials. So that was great. So here's kind of the visual representation of how it's done in Flyte. You have here in the left-hand side the potential clients first will be the resource owner or the user who will make use of both CLI tools or the UI to access Flyte admin, and the protected resources will be probably the workflow executions and whatnot. So Flyte comes with a native OIDC client. OIDC is used for the identity part of the problem, and you will every time you enable auth, you will make use of OIDC, right? The kind of the question is what level of feature set you will need for the authorization part, for the auth server implementation. Flyte admin also comes with an internal authorization server, but it's kind of limited. It handles some scopes, predefined scopes, and it will store the secrets for the authentication of both the CLI tools, the access to the Flyte console, and Flyte propeller, which is not client-facing, not user-facing, but for the auth implementation, it comes as a client, right? Remember, the Flyte propeller is the controller that will handle the execution of workflows in the platform, in the infrastructure. So if you, by default, it's enabled and you can use it, but if you need something more, with more feature, let's say, or your organization needs more control around the scopes, policies, and all of that, you will need to use an external authorization server provider, but it's provided by your identity provider. Basically the same mechanism you will use, or the same component of service you will use for identity, you will use it for building a custom auth server. And the whole idea of the PR that you will find in the notes is basically to update the instructions on how to implement all this stuff, be it using Okta, Keycloak, Google, and partially Azure AD. This is work in progress and trying to improve on that part. But I'm really thankful for all the interactions I had with community members, including Michael, who's here, and many others who were struggling or are struggling with auth. And with them, we learned a lot of lessons, and most of that is in that PR. Because the implementation itself of the auth implementation in Flyte, I think it's great. But I think what we needed was better instructions on how to make a better use of it. So yeah, with that, I will maybe real quick demo. So kind of let me see. Yeah, I don't know if that's better, but kind of the expectation, for example, for the Pixie flow is something like this. If you try to execute a workflow from the command line, it should point you to your IDP. In this case, I'm using Okta, and the data plane is on AWS. So let me see if I remember. And flytectl, and it should emit an authorization token. It will send it back to the service, and here's the operation. When you obtain the token is not there. And from that point on, the execution goes as usual. So it's the same for the user interface. Every operation, in this case, now that I already log in, and if the token is not expiring, I will be able to use the same for further executions. You can also tweak this, the token expiration policies and all of that. But this is how the Pixie flow will look like in real life of some sorts. So, well, that's it. Any questions so far? No. Yeah, I know that was quick, but hopefully the PR will be better for you to understand. All right. If no other question, well, it's my pleasure to move to the next item in the agenda. And welcome here, Chia. I hope I'm pronouncing your last name well. co-founder on at Eventual Inc. and core Daft maintainer. Welcome, Jay. It's great to have you here.
Yeah, thanks for having me. And yes, you pronounced it well. It's Chia, like chia seeds.
Oh, that's great. Cool. Yeah, great to have you. So, would you mind briefly introducing yourself and probably sharing something you enjoy doing outside work?
Sure. Yeah. So, hi everyone. My name is Jay. I currently am a co-founder at a company called Eventual. We are building an open source tool called Daft, which I'll be presenting about today. Before Eventual, I worked at Freenome and also Lyft Level 5. So, funny enough, two very big consumers of Flyte and contributors to Flyte, I guess. Was part of some of the first discussions at Freenome about which workflow engine we were going to use, and then Flyte, kind of came out on AWS reInvent, and so that was part of that whole transition into Kubernetes and Flyte for Freenome, and building out a lot of the machine learning data infrastructure there. And then later on, when I went to Lyft Level 5, I ended up also building a lot of the distributed ML data infrastructure at Lyft for all these autonomous driving cars and imagery and LiDAR and radar and all these multimodal data mediums. Yeah, so I've been working in this space for quite a bit, and I guess found my way eventually starting my own company to build ML tooling for these data modalities, right? So things that don't really fit in a table, genomic files or images or tensors and things that we deal with on a day-to-day basis, but for some reason this doesn't fit in a SQL table a lot of the time. I guess what I do for work outside of work for fun, I like to rock climb. Me and every other, I guess, software engineer in the Bay Area. But yeah, I climb a lot. So if anyone ever goes to Dark Patch Boulders, hit me up in San Francisco. Yep.
That's awesome. Really interesting. Thank you.
Cool. Should I launch into my slides then?
Yeah, sure.
Okay, awesome. So yeah, I prepared some slides for today's chat. And let me know if this slideshow shows up for everyone. Which okay, should be good. So yeah, so I'm gonna present to everybody today about Daft, which is the data frame library we've been working on. I call it the Python distributed data frame for complex data. It's quite a mouthful, but really the main idea is that why can't I have all my data in a table, right? Why can't I have my images? Why can't I have my tensors? Why is it only limited to strings and dates and numbers, right? Why is it like Excel? Like we're working in Python. We should be able to have Python objects. There should be native types for everything. And so I'm going to skip over this because I just did give a brief overview on my background and jump straight into the talk. So today's talk, we'll be talking about multimodal data engineering, right? Multimodal here meaning different modalities, different rich types such as images, and potentially even having different views on the same data, right? For example, you may have images of a scene, but then also maybe have LiDAR or some audio. And so this multimodal view of your data. And then we're going to be talking about how to do this data engineering on multimodal data using both your ML and Python kind of code, right? Stuff that you've been working on, algorithms, custom algorithms that you've been developing, and SQL relational operations. Because a lot of the time when you do data engineering, you're not just processing the data with your Python code, you're doing a lot of analysis, right? You're using the table abstraction to do joins, to do group bias aggregations, to understand your data. When you're working with images, you want to understand, are my images all the same size? How many people are in these images? Can I group by, say, a location and count the number of people? And these are all things we have to do when we're doing data engineering. And combining these two things together really makes multimodal data engineering work. So again, I have here an illustration of what this is a Daft data frame. What the world would look like if you're in Daft, right? You can have any kind of data really in a Daft data frame, and we have native types right now for images, embeddings, tensors are coming out soon, and so the idea is that we have a data frame that's capable of working with all these complex types. So I'm gonna make that a little bit more concrete by, doing an XKCD style, situation where so that people can understand where Daft may be useful. All right, so let me know if this sounds familiar, but imagine you have some cloud object storage and then a database, right? Very common. And then oh, I have some JPEG images in my object store in S3, and then you also have some URLs and some metadata in a database sitting out somewhere that points to your cloud object store. Very typical setup, a very common setup that we see. And then your boss says, hey, Jay, we need a clean data set, right? So I'm like, okay, I roll up my sleeves. I'm like, okay, how to do this data set curation, right? I'm going to get a promotion. I'm going to do data set curation. And then, I'm a good data scientist. So I'm going to start by visualizing the images, right? Data science 101, always visualize the data first. Okay. So I go to my relational database, I write a SQL query. I'm like, okay, now I export a CSV file. I load the CSV file into my Python notebook because I need to run some Python code now. And finally, okay, an hour later, okay, I'm looking at my pictures. I'm like, okay, a lot of these pictures are pretty dark, right? Maybe I need to add a new brightness field to get a clean data set. I need to filter out all these dark pictures. So now what, right? It's like a million images. How do I run this? So okay, no problem. I'm going to write a simple Python function, probably 10 lines of code, pretty simple. I'll just count the brightness of each pixel and average it, right? But now I need to run it on all the files. So I'm like, okay, how do I do this? I need to use the cloud, right? Quote unquote, the cloud. So I go to my team infra channel. I'm like, that channel, help me, please. I need to do this in the cloud. I need to run on all my images. 1 week later, I'm like, oh my God, finally. I processed all these 1 million images. I collated the 1 million images, all the metadata about the brightness and all the other metadata into a CSV file. Who knew I had to learn Kubernetes, Docker, and Flyte, and Kafka, and Spark, and all these different tools to just get this one simple task done, right? But it's okay. At least that's done. I never have to do it again, right? Famous last words. But yeah, I'm done with it. I don't want to do it ever again. So I upload the CSV into BigQuery. I join it back with my table. I make a new view, right? I do some aggregations and group by to make sure that the numbers look good. I'm getting the brightness values that I want. Now I'm like, okay, let me dust off my old Python notebook and visualize again. Like, oh my God, why are there so many sky images? Right now that the brightness is gone, I'm getting all these images of the sky. Like, no wonder my model is doing badly. Right? I'm trying to detect people. There's no people in the sky. So okay, I start all over again and I start crying internally. Right. So this is kind of like the process I think that a lot of developers go through when they're working with these two multimodal data types where data doesn't really fit in a database, but then you have these two systems that you use to process this data, right? So the problem here is the modern data stack is pretty ill-equipped to handle this multimodal complex data workloads, and we often maintain two separate systems, right? One for your tabular data, that's usually things like BigQuery, Snowflake, Postgres, your databases, right, that handle strings, URLs, and dates and numbers. And then you have another data system for your complex data, multimodal data, whatever you may call it. Things like images, JSONs, CSV files, XML files, PDF files, and maintaining these two separate systems and working with them significantly slows your iteration cycles, right? Because as a developer, now you're maintaining consistency between the two systems, you're running queries over two systems, and that's a very non-iterative process. And it's not just images, right? Data is very messy and very complex at the ingestion point. So at whatever company you work at, at the ingestion point, at the kind of boundaries of your system where you interface with the outside world, you're getting all this data like CSVs, NumPy arrays, protobufs, JSON, XML, PDFs, logs, and it's really, really messy and really complex, and often doesn't fit in your SQL table. And you need a way to get it into your SQL table first, do some iteration, and potentially close that loop and go back again to do that loop. And so really Daft here is meant to be the solution, where now my stick man is happy, because Daft just works really well with something like a cloud object storage, right? You don't need a separate database. You just need a cloud object store like S3, and then you need something like CSV or Parquet as your table format. And then all of a sudden you have a functional kind of way of doing both your relational queries on top of these tabular files and also anything else you want to do. And that's because, again, Daft is really good at relational queries, and we ingest CSV, Parquet from S3 really, really efficiently. We're also really good at complex data processing. I'll demo a little bit about that later with images. We have these native kernels we built in Rust for common operations, such as resizing images or converting images to tensors. And we also let you run your own custom Python code really easily, right? We have a concept of a user-defined function, a UDF. So you just write a Python function, and that Python function will probably take in something like a NumPy array or a Perl image, and then you can just run that function on top of a Daft table really easily. The third thing is that we're distributed, right? So you can scale up to the terabytes to the petabytes on a distributed cluster, something like Ray. And this is important because oftentimes when you're working with these multimodal complex types, the data can get quite large because you're no longer dealing with every row doesn't just contain a string or a number in 64 anymore, right? A row could contain an image, a row could contain a PDF. Or an audio file, and those things do get pretty large, and then you want to start leveraging the distributed capabilities of something like a Ray cluster. And last of all, Daft is really fast. We've built a lot of our kernels in Rust, optimized a lot of the I/O, and so we're about 3 times faster than EMR Spark right now. We have on our blog published some benchmarks, so go take a look there. But yeah, it's constantly improving, and we're constantly identifying a lot of these bottlenecks in Daft to make it run even faster. The idea here is that it should be really nice to use interactively in a notebook, but also when you start running in a production setting, on large scale data in a kind of a batch setting, it should be really, really fast and have high throughput. So why at a Flyte meetup, right? So I've used Flyte for quite a bit. I think that, beyond the similar taste and color schemes, where we both like purple, great taste, that Flyte. Beyond that, I think Flyte really excels at automation, reproducibility. Right, these are all things that you want to have in a workflow engine. But below the workflow engine, you kind of want also a data processing utility, a data engine, right? That the workflow engine then orchestrates. And I think Daft is a perfect fit for that. It allows you to scale up from just a single task, single node into a distributed cluster with Ray, and I'll demonstrate some of that later on. But with Flyte and with Flyte and Daft, you have this kind of all-in solution for a lot of your batch data processing needs. So yeah, let me launch into my demo. So I have just as a simple illustration, I am that stick figure again. I'm now going to do some interactive munging of my data, right? So first off, I'm going to read this Parquet file that's available on Hugging Face. It's one of the Lion datasets. If anyone's been following along with generative AI and all that hype, it's a dataset with a bunch of images and also a description of those images. I'm reading that with Daft. It's pretty simple. Read Parquet, right? Daft.read Parquet. This takes in HTTPS. You can read S3. You can read your local files. And I'm selecting from the data frame 3 columns: the URL, text column, and then this custom column they have called an aesthetic score. How pretty are these images, essentially? So also Daft is what we call lazy. And so when you execute these functions, you have to tell Daft to execute, right? Otherwise, it just kind of collects them in a plan or kind of like a queue almost, and will only execute it when you tell it to run, because we run a lot of these intelligent optimizations under the hood. For example, when you read Parquet, we don't read the entire file, right? Because you've told us that you only need 3 columns. And so when this is executing, it's only pulling those 3 columns down, and then I'm only showing 5 rows. And so it's very efficient with the I/O and optimizations there. So yeah, this is kind of what the data looks like in our data frame. There were a lot more columns, but I've pruned the columns down to these 3. There's a URL. These are just images, right? And I can pull up one of these images. Yeah, it's just images sitting around in random places on the internet. Very dirty data. Some text describing that image, also very dirty text, and then the score. Cool. So same thing. I want to filter my data set maybe for where these strings contain darkness, right? Maybe I want the dark photos, just like in my example earlier. So I can just do a filter, right, on my data frame where the text column contains darkness. So Daft has this very powerful expressions API that lets you express your computations in Python But under the hood, when this is running all in Rust and very, very optimized code in Daft itself. And so once you filter, you get all these rows where they contain darkness. There's no light without darkness, right? The top 3 corners is filled with roiling, deeply shadowed clouds, and something about darkness way too long. I can't read this. But yeah, so now, cool, we have this, but how do we start working with the complex data, right? So far, we've only really worked with like text data and numbers, but let's, maybe pull some images down. So again, we provide super easy utilities. Right now, we have this .url.download utility, which when we run it on this URL column, brings it from right now it's a string column into a bytes column, right? And then we have another kind of expression. It's a .image.decode expression that takes a byte column into an image column. And so in one line of code, we've kind of gone from URLs to images, right? And images, again, are native types in Daft. And so now we have a Daft image column. It tells us mixed because these images are from random sources on the internet, and they have different sizes, they have different number of channels and all that as well. So it's a mixed image column. But yeah, these are all the images. And I'm going to run a very simple pre-processing step here, which is very common in most machine learning steps, which is just make these images the same size, because right now they're all of different sizes. So a lot of these, again, common operations that you will want to run on your data, Daft provides you utility. So here I'm saying, take the image column from the filtered data frame, run .image.resize, right? Resize this column into 32 by 32. I show 5 rows again. And yeah, so then this, by showing 5 rows, we only run it on the first 5 rows. So we only pull down the first 5 rows of data and the images, and we have now these like super pixelated looking, because they're all 32 by 32 resized images. Then, I can do something like write it back out to Parquet, and then I collect it. This will tell me what files I've just written, right? So a very simple kind of workflow, but Daft also, will support doing things like aggregations, right? Maybe you want to count the number of occurrences of the word darkness in your data frame, or you want to maybe do an average of the aesthetic score of all these images. Those are all also very possible, very typical data frame operations with Daft. The last thing I did not demo here, which is important to call out also, is the ability to run Python functions. And so if you had a custom model you were trying to run, you can just run a Daft user-defined function, or UDF for short, on these columns, and run a PyTorch model, run any OpenCV, or convert it to a tensor and run NumPy, whatever you want really. So that's kind of how you would play with Daft in a kind of interactive environment, right? So maybe now you're ready to go into production, let's say. And one really good way of doing that is with Flyte, because Flyte gives you this ability to do reproducible pipelines, right? Reproducible batch workflows. And so I've gone ahead and written a simple Flyte workflow with one step, just to demonstrate it. This is my Flyte workflow. It has one step, which is called produce resized image dataset, which is very literally produced as a resized image dataset. And it takes in a limit, right, which is the number of rows you want to run. And this step, all it does is it runs that same code we had in our notebook earlier, except that I've removed all these dot shows, because these dot shows are just for visualization in the notebook. And by removing the dot shows, I've essentially made this into a lazy pipeline that I can then execute all the way to the end, right? So this is the copy code from the notebook without the dot shows, and all the way at the end, I just write to Parquet, and then I return the written data frame. So let's try and run this and see what that looks like. Let's see. So here I'm going to run. So I have running locally a sandbox environment for Daft that I can then go ahead and run. So when I run it, it's, if you've ever used Flyte before, nothing too special. It runs a workflow, and this workflow runs a single task, and this is running Daft under the hood, right? Some interesting things to call out here is, number one, I changed the runner for Daft into a Ray runner. And this is running right now in a Ray cluster, right? Because I've told Flyte to start a Ray cluster. I'm using the Flyte Ray plugin to start a Ray cluster on the side. And then when Daft is running, it just automatically picks up, hey, like, Flyte is already running Ray, and so it connects with that Ray cluster, right? So if we go back into our actual Kubernetes environment, we'll see these clusters running, and these are the clusters that have been started by Flyte, and Daft is actually running on these clusters. And so right now, the cluster is pretty small because this is running on my laptop. I have one replica of Ray Worker running, but if you're running in the cloud on your actual Kubernetes cluster, you could scale this up to like 100 replicas, right? You could allocate it GPUs and have Daft leverage these GPUs when processing. Really, it's very, very, very flexible, and you can do whatever you want, and have kind of Flyte and Ray handle the infrastructure portion, but then use Daft as kind of this interface to your Ray cluster, this data frame interface, which gives you all the power of having the relational queries and also the data processing queries of data frame. And so let's check our task. Yep, the task has succeeded. It outputs, we dump data to this location, and this stuff all ran on Ray, right? So let's see if it displays it correctly. Yeah, so when you go to the graph view, you'll see that this was a Flyte Ray task, which means that this task was not running on a single pod, it was actually being driven by that pod, but running on a cluster of pods, a Ray cluster. And so this was a super simple example, but you could, potentially use Daft for more complicated, complex workflows. For example, here I have one dummy workflow which runs, maybe you can use Daft to query some data, and then you can analyze that data in a separate task using Daft as well, right? Doing group bias aggregations, but then you can pipe that data into training and then use Daft for evaluation. And so with Flyte and Daft, you kind of have this power for processing your data and kind of orchestrating it all in one interface. So that was it for the demo. I guess to round up my presentation today, I'm going to talk a little bit about like what's on the roadmap. So tensors are coming soon. We have native tensor type columns, which is really exciting for us, and nice PyTorch integrations too. So that's, I think, landing in about a week or two. We're optimizing a lot of the S3 IO in Rust. URL download that you saw earlier has already been, I think, about 5 times faster than most other solutions we've tested, but it's about to get 3 to 5 times faster again, because we've built a lot of our own S3 IO in Rust to make that really, really efficient. And we're working with Amazon to make that happen. We are building a PyTorch data loader. We do have a local version of this working, but then we're also working on a distributed story. So if you're doing distributed training and you need pre-processing for that, come talk to us and we'd love to work together. And then last of all is just working on robustness. We're working a lot of benchmarks and working on a lot of chaos engineering, right? Run the thing, kill all the nodes and make sure that we still work. And so these are all things that are on the roadmap for Daft. And if you already have a use case that we don't cover, come chat with us. We'd love to collaborate and work together. Yeah, that's it. That's all I have for the presentations. Open to any questions that people might have.
That was great, Jay. That was awesome. And thank you for the demo. All right, any question for Jay? Yeah, Jeff.
Hey, yeah, thanks. Jay, just a couple of questions. So you showed a DAG, with a slightly more complex DAG that uses both Flyte and Ray. Can you comment on, could you achieve that level of orchestration with Ray alone, or why might you use, sorry, not Ray, well, Ray and I guess Daft on top of Ray, but why might you use Flyte in that kind of a situation?
Yeah, that's a really good question, right? A lot of the DAG workflow engines have this, whenever I use a DAG workflow engine, I ask myself this question a lot, where do I draw the boundary between tasks, right? I could technically make every line of code a new task in my program, but obviously you don't want to do that. And so I think the way you want to do it is you want to organize your workflow based on steps that you want to be atomic and reproducible, right? So in this case, for example, my query data node, right? I want that to be like its own node because I might want to re-query the data, rerun it, or have that step cached. And this can run as a single Daft data frame, and then I can, after the workflow finishes, I can store it and then pass maybe a pointer or a small data frame to the next step. This step here, the analyze dataset step, could run together with the query dataset step, but by having it as a separate step, it makes it very reproducible because then you can unit test it separately. You can, run it on a different dataset and have that be kind of this idempotent stateless piece of code that you can have on the side, right? So I think the question of where do you draw the lines is really a question of how do you organize your code and how do you make your code reusable. And I guess the last thing to call out is that it is true that like Daft can't do everything. A data frame is not the answer to every problem, right? Training, for example, you don't really train using a data frame. That's not the appropriate abstraction. You kind of need something more like a data loader, right? For distributed training, you want a distributed data loader. And so what you would do is you would factor that out as a separate task, have that run on the appropriate abstraction, but have that interface with all the other steps through the appropriate APIs. And that's why I brought up run training here as kind of a separate step. But I mean, long story short, it really depends on the application and what you're trying to do and how you want to organize your code to make it reusable and reproducible.
Awesome, thank you. I'm happy to yield to anyone else that has any question, but I do have one more that didn't come back and ask that question.
Yeah, I had one. I don't know if it's the same as yours, but what will be the scope of let's say a potential Flyte and Daft integration? How would it look like?
I mean, I feel like we're already pretty well integrated because we ran on Ray, so I didn't really have to do any changes. I literally just like my code was just start the Flyte task as a Ray task, right? And then I just said Daft use Ray, and then it picked up the Ray connection that Flyte was already producing. It worked pretty well. One thing that would be nice is, I guess, more tight integration about how do I pass data frames between tasks. That could be really cool. Right now, the way that I would do it is I would write the data frame back out into S3 and then read it back in from a different step, which is actually fine for a lot of these workflows because, like I said, your steps are kind of very atomic and kind of can run independently from each other. And oftentimes you do want to checkpoint in between by writing data back up to storage. But it could be really cool to be able to pass these data frames back and forth between steps, because what we've done is that we've made these data frames very lazy, right? So when you run, say, this code, it runs immediately because we're not executing the code, right? So if you print this, it'll say like, hey, like your data frame is not materialized, and that's because under the hood, it's actually just this object, which is a plan. This is a plan of how we are going to run. And so if you can serialize this and pass this around between the Flyte work between Flyte steps, then it could get really, really powerful.
Sounds great. Thank you.
That's cool. I'd like to understand sort of your thoughts on how we would achieve this serialization and passing of these, I guess, unmaterialized data frames between tasks or whatnot in a lazy way. Is that what you're thinking, or?
Yeah, exactly. You don't have to execute it if you don't need to, right? So you can have these tasks add operations on as they need to, and then you can have one final task that will just be like, yeah, execute. Or you can have intermediate tasks that will perform analytics. Oftentimes it's the way that a lot of these workflows work is that you have kind of a main path for data processing, and then you have kind of these branches out that will perform analytics as you go along, right? Like how many nodes does a column have, these sorts of analytics on the side. And so your main branch can be fully lazy. but then your side branches can execute just the pieces that they need on just the filters that they need, if that makes sense.
Yeah, thank you.
All right. Any other question? Jay? All right. Well, again, thank you, Jay, for sharing. Thank you for joining. It was great. I think we'll need to follow up for the potential collaborations here.
Yeah, let's do it.
That will be awesome. Yeah, thank you. All right. Any other question? Any other comment? Your last chance. No? All right. Well, that's it for today. Thanks everyone for joining and hope to see you in the next one. Goodbye.